Hello everyone, in this video we're going to talk about the transformation in geometry known as a dilation. So we've looked at rotation, reflection, and translation, and those three transformations are similar in the fact that they are considered congruence transformations. So when you do a translation, reflection, or rotation, the shape that you are transforming keeps the same size and the same shape, right? It stays congruent. While dilation is a little bit different, it's a similarity transformation. So when we dilate a shape, we are changing its size, but we're not changing the shape, right? If we're dilating a triangle, it's still going to be a triangle, right? But it might be bigger or smaller, so it's not congruent. We call it similar. So that's how a dilation is a little bit different. So a dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point, C, called the center of dilation. Most often, pretty much 100% of the examples we're going to see, the center of dilation is the origin, okay? And the scale factor, which is K, so K is our variable that represents a scale factor, which is the ratio of the lengths of the corresponding sides of the image to the pre-image. Okay, so the pre-image is going to be our original shape, and the image will be our new shape. Okay, so sometimes I say, in order to find the scale factor, you can do new divided by old, right? So that could be a corresponding side length or a corresponding distance, just depending on what the question is asking you. Okay. A couple other things to note: when K is greater than 1, we call that an enlargement. And when K is between 0 and 1, so 1/2, 1/3, something like that, we call it a reduction. Okay. All right, so let's look at a couple examples. Example 1 says, in a dilation, AB prime equals 3 and AB equals 12. Find the scale factor. Is this an enlargement or a reduction? So we have to remember our prime symbol here represents our new shape. Okay, so this will be the new shape. This will be the old or the original shape, right? So remember, right here I said K is equal to new divided by old. So we could say the scale factor is equal to the corresponding sides, so 3 divided by 12. So we can say the scale factor is 1/4. And since that is between 0 and 1, we would say this is a reduction. So our shape or our line segment got smaller here. Okay, so that's a basic example just to identify scale factor. All right, let's talk about coordinate rules for dilations. So if point A, which has the coordinates x comma y, is the pre-image of a point, so the original shape or original point, then its image, or the new point, after a dilation centered at the origin with the scale factor K is the point A prime, and we do Kx, Ky, or in other words, we multiply the coordinate, the x and the y coordinate, by the scale factor, okay? All right, so we're gonna do example 2 here. We're gonna dilate triangle ABC with a scale factor of 3. So let's write down our coordinates, and then we're just gonna multiply our coordinates by our scale factor, which is 3. So point A, we're at -2, -1. B is -2, 2. And C is 1, 2, 3, 2. Okay. So now we're going to say A prime, B prime, and C prime. So we're just going to multiply these coordinates right here by 3. Okay, so if we do our x coordinates, let's say -2 times 3, so we have -6. -6, and 9. Hope that's going to fit on my graph. And our y coordinates now. We're going to multiply these numbers by 3. Okay. So -1 times 3, -3. 2 times 3 would be 6, and 2 times 3 once again would be 6. Okay, so now these are the coordinates that we will plot. So A prime, -6, 1, 2, 3, 4, 5, 6, 1, 2, 3. So there's A prime. B prime, -6, 1, 2, 3, 4, 5, 6. B prime. And C prime, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, my graph's not quite big enough, but about right there. Okay, so we'll call this C prime. Okay, and connect our points here. And we have our enlarged shape, right? We enlarged it by a scale factor of 3, so our shape got bigger, but notice it's still a right triangle, okay? All right, let's look at an example where our scale factor is between 0 and 1, right? So we're going to make our shape smaller. We're going to do a reduction. So we're going to say E, F, and G. So E is 0, 1, 2, 3, 4. F is negative 1, 2, 3, 4, 5, 6, negative 1, 2, 3, 4, negative 6, negative 4. And G is 1, 2, 3, 4, 5, 6, negative 4. Okay, so we're going to multiply these coordinates by half. So this would be 0, 2, negative 3, negative 2, positive 3, negative 2. All right, so now these are the points that we're going to graph for our final shape. So 0, 2, call that E prime, negative 1, 2, 3, negative 2, F prime, and G prime is 1, 2, 3, negative 2. So now we connect our points, and now we have dilated our triangle with a reduction by a scale factor of 1/2. Okay. Last thing we're going to talk about, what happens if our scale factor is negative? Okay, that could happen. What it does is it dilates the scale factor by k, so that's still the same thing. However, it also performs a 180-degree rotation. So if we think back to our rotations video, if you want to take a look back at that, look up in the right-hand corner right now. I'll post a link to that. But what we do for a 180 rotation is just make x and y opposite, right? So we're still going to multiply x and y by our scale factor k, but then we're going to make both of those coordinates opposite. Okay, so that's what this right here is telling us to do. Example number 4, we're going to dilate triangle FGH by a scale factor of negative 1/3, right? So we're going to start off and we're going to say F, G, and H. So F, we have 1, 2, 3, 1, 2, 3, so 3, negative 3. G is 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, so 6, 6. And H is 3, 6. So F prime, G prime, and H prime. All right, so when we look at F, we're going to dilate by a scale factor of negative 1/3. So we can multiply those coordinates still by negative 1/3, right? So 3 times 1/3 would be 1, and then we could change it to negative 1. Negative 3 times negative 1/3 would be positive 1. 6 times negative 1/3 would be negative 2. Same thing for our y coordinate. And negative 3, or 3 times negative 1/3 would be negative 1. And once again, we have negative 2. So now we can plot these points. And when we plot these points, it's gonna be a scale factor, a dilation with a scale factor of 1/3 with a 180 rotation. Okay, so let's plot them and see what it looks like. So negative 1, 1 will be F prime. Negative 2 will be G prime. And negative 1, negative 2 will be H prime. Okay, so let's connect our points. And that looks pretty good, right? So we have a reduction by the scale factor of 1/3, so our shape got smaller. And we have a rotation, right? So all of our points, right? F was at the bottom of our shape, now it's at the top of our shape, right? So we had a 180 rotation, and we end up with our final shape. And that is how you dilate shapes in geometry.